of the negative binomial distribution. This is group 4. Basically, for negative binomial distribution, it belongs under the discrete random distribution category. So for the mean, which is also known as E of x, also known as the mu, is given by the formula summation goes up to infinity, x is equals to 0, x, p of x is equals to x. But our probability mass function of the negative binomial distribution is given by x plus r minus 1, r minus 1, p, x into 1 minus p, r. So we are going to substitute this into the formula for the mean, which is this summation infinity x is equals to 0, x into x plus r minus 1, r minus 1, p of x into 1 minus p, r. So for discrete, when you try substituting in this one, when you put in here 0, the whole thing goes. So we're left with, this becomes 0 plus the summation goes up to infinity. This is x is equals to 1, x into x plus r minus 1, p of x into 1 minus p, r. So we are going to first deal with this. This is x plus r minus 1, r minus 1. It is the same as x plus r minus 1 factorial over r minus 1 factorial into x plus r minus 1 minus r minus 1. This is all in a curly bracket factorial. So this is the same as x plus r minus 1 factorial into r minus 1 factorial into x factorial, because when you substitute in, the error goes and also the one goes. So we're substituting this, but also we have to get simpler version of this. R factorial, this is the same as r over r into r minus 1 factorial. When you simplify further, this is the same as r factorial. So we are going to substitute this into our equation 1, which is given by the mean, also mu, substituting, this is x is equals to 1. We have to say this one is given by, so when you substitute in, here is x, also r factorial into this one, we have said this is x factorial, this is p, x, 1 minus p, r. So I'm going to expand this. Infinity, x is equals to 1. This is x dot r into x plus r minus 1 factorial over r factorial into x minus 1 factorial. This is the same as x minus 1, p power 1. This is 1 minus p, r plus 1, 1 minus p, negative 1. So when you try to simplify this and this dies, so we are going to remove out those ones which are not affected by x. We have in r, because it has no effect on the x. Also we have p, we also have this one, which is 1 minus p, negative 1, summation infinity x is equals to 1. So from this, we're left with x plus r minus 1 factorial over r factorial into x minus 1 factorial. So here we're left with p, x minus 1, 1 minus p, r plus 1. So we are going to make some assumptions and say let w equals to x minus 1. So when x is equals to 1, w is equals to 0. This x can also be written as w plus 1. So we also let s is equals to r plus 1. Then we have our r is also equal to s minus 1. So we are going to substitute this into our equation here. This is rp over 1 minus p, here negative 1, summation infinity. So here we're having w is equals to 0 for x is equals to 1, like the way it was here. So here it comes to 0. We have our x we have said is w plus 1, so plus r, which is plus s minus 1 minus 1 minus 1 over, this is factorial, over r factorial, r is the same as s minus 1 factorial. Then here we have w plus 1 minus 1 factorial. This is pw, because this one stands for that. We also have 1 minus ps. So we are going to simplify. This is rp into 1 minus p, summation w is equals to 0. Here you're left with w plus s minus 1. This is all under factorial over the s minus 1 factorial into w factorial into pw 1 minus ps. So from this, shall say, but the summation goes up to infinity, x is equals to 0 plus s minus 1 factorial over s minus 1 factorial w factorial p 1 minus ps. This is the same as the factorial, infinity, x is equals to 0, w s, this one is equals to 1. So I'm going to substitute in all this one. It is equating to 1. Therefore our mean is rp into 1 minus p into 1. Therefore the mean is given by 1 rp into 1 minus p. This is our mean. Deviation. Standard deviation is very well known as the square root of variance. So for us to get the standard deviation, we have to first get the value of x, which is given by the formula, this one, the mean minus the mean squared. So after getting the mean, we are going to first consider. So for the variance, that's the formula, expectation of x squared minus the mean. So we are going to first consider the expectation of x squared. So from this is also known as the p. If we had to work on this for the expectation of x squared, is also known as this. This is x is equals to 0, x squared dot p of x is equals to x. So this one we are going to substitute in the mass function. The expectation of x squared, this one is given by x is equals to 0, x squared dot x plus r minus 1 p into x into 1 minus p, which is r, which is our probability of failure. So when you try feeding into this one, you notice that we are left with 0 plus summation. This one we have x is equals to 1. We have x squared into x plus r minus 1. This is the p of x, 1 minus p r. So since the one for x is equals to 0 vanishes, we are going to consider this. We are going to first work with this, which is given by the summation infinity x1, this is x squared into x plus r minus 1 px into 1 minus p r. So we are going to work on this also. This is x plus r minus 1 is also given by this. This is the same as this, in fact, over r minus 1 factorial into x plus r minus 1 minus r minus 1. So I'll just put these big brackets for purposes of getting confused. This is r minus 1, x plus r minus 1 factorial into r minus 1 factorial x factorial, because the other ones cancel. So I'm going to substitute in also for this, which is r minus 1 over, do it from here, 1 over r minus 1 factorial is also equal to r into r factorial. So I'm going to substitute that into the equation, which is into our equation, our equation 1 there. So this one is given by the summation, it goes up to infinity. This is x is equals to 1 x squared into, we have said this is the same as x plus r minus 1 factorial over x factorial into r minus 1 factorial dot p of x 1 minus p r. So we are going to expand this. When you expand this, this is x is equals to 1, x squared. We are looking for ways of it to introduce the other, this one, because we had not yet introduced it. We have r into r factorial, the p of x 1 minus p r. So I'm going to expand this. When you expand that, this is x equals to 1, this is x squared, r into x plus r minus 1 factorial into x minus 1 factorial r factorial. This is px into 1 minus p r. So you notice that at least here one x dies. So we're left with x is equals to 1, we're left with x into r into x plus r minus 1 factorial over x minus 1 factorial r factorial px 1 minus p r. So I'm going to look for ways of moving out those ones that are going to first expand this. X is equals to 1, this is x into r, x plus r minus 1 factorial. This is the same as x minus 1 factorial r factorial. Here we're left with x minus 1 p power 1. I think it's the same with this. I have also this r plus 1, then also 1 minus p negative 1. So it comes back to this. So we are going to extract out those that are not affecting x. We have r, we also have this p, we also have this 1 minus p. I'm going to put it just over into summation x is equals to 1. Here we're left with x into x plus r minus 1 factorial over x minus 1 factorial r factorial. Here we're left with p x minus 1 1 minus p r plus 1. So we are going to make some assumptions. We are going to let w is equals to x minus 1. So when x is equals to 1, our w is 0. So our x is the same as w plus 1. Also let for s, let s is equals to r plus 1. Our r is the same as s minus 1. So we are going to substitute this into this. This is rp into 1 minus p summation. This one we have said w is equals to 0, left with x into, here when we substitute in, we are going to have our x is what? X is w plus 1 plus, when you substitute in for r, it is s minus 1 minus 1. This is factorial over our x, which we have said is w plus 1 minus 1 factorial. R factorial is the same as s minus 1 factorial. This is p w 1 minus p. We have s. So we are going to transfer this p summation w is equals to 0. Here we're left with x into w plus s minus 1 factorial over, said we had factorial p w 1 minus p s. So this is what we had, but we know from what we did this side, we said our x is equals to w plus 1. So I'm going to introduce it here. This is rp into 1 minus p summation x is equals 0. This is w, not x, sorry, 0. Then you have w plus 1 into w plus s minus 1 factorial over w factorial into s minus 1 factorial p w 1 minus p s. So I'm going to try to expand this. I'm going to expand this. I see what I get. This is 1 minus p. Then you have, this is w is equals 0. This is w dot w plus s minus 1 factorial over w factorial into s minus 1 factorial p w 1 minus p s. So we had also plus this one plus the summation. This goes up to summation. This is w is equals 0. Here we had w plus s minus 1 factorial, have pw into 1 minus p s. This is all over w factorial s minus 1 factorial. So this one, it all comes back to 1 when you simplify it. This one is infinity, w is equals to 0, w into w plus s minus 1 factorial over w factorial into s minus 1 factorial pw into 1 minus ps plus 1. So I'm going to look for ways of working out this. From this, yes, from here, this equation alone, it looks like the equation of the mean, which we earlier worked it somewhere here when we are deriving the mean. It resembles the equation of the mean, so which is this. So we are going to just make a comparison, then we feed in. This is RP into 1 minus p. This is the same as RP 1 minus p plus 1. So, but we said for this case we are not having, in the mean we had r, so for this case we have s. So this is RP into 1 minus p, then we have sp over 1 minus p plus 1. So we are going to simplify this. This is RP into 1 minus p. So when you get there the same, this is that, but our s, we said s is the same as, from what we did, s is the same as r plus 1. So we are going to just substitute in this side r plus 1 into 1 minus p, purposes of not forgetting. This is RP into 1 minus p. So when you work out this, you get RP plus 1 minus p over 1 minus p. So when you look at this and this cancels, left with RP into 1 minus p into RP plus 1 over 1 minus p. So we have been deriving for this, but our general formula for variance is this minus the mean which we earlier worked on. So this is the same as RP into 1 minus p, RP plus 1 minus p, minus the mean squared, which is RP 1 minus p squared. So when you try to expand this, when we try to feed this into this equation, we have RP over 1 minus p squared plus RP into 1 minus p squared minus RP 1 minus p squared. If you notice, this and this cancels, we're left with RP into 1 minus p squared. So this is the variance, but the question was asking for standard deviation. Standard deviation is given by the square root of variance. So here we are having RP into 1 minus p squared. So this is the same as RP 1 minus p. So that's how you get the standard deviation of a negative binomial distribution.